This is R.D. Sharma solution, class 12, chapter 19. Exercises 19.9, indefinite integrals we are talking about. Sine inverse x whole cube and divided by under root 1 minus x square. Sine inverse x differentiation will directly give us 1 by under root 1 minus x square. There is no catch in this question. So just assume t equals to sine inverse x, differentiate it. You will get 1 by under root 1 minus x square. Dx goes on the right hand side. So this whole is dt. And how about the sine inverse x? It was already taken as t. So this will be t cube, and this dx by under root 1 minus x square will be dt. So this will be t raised power 4 by 4, x to the power n plus 1 by n plus 1 formula I have used, plus constant of integration. In place of t, just write sine inverse x to the power 4 divided by 4 plus constant of integration. That's your final result. Now this is a very straightforward question. You can just try it by yourself also. Now log x. Log x differentiation is always 1 by x, that we have known. But my logic is that whenever you have a constant around this log x or any term, take all the term as t. That is, t equals to log x is not that better than 2 plus 3 log x. So when we differentiate it, 2 will go and we'll just be having 3 by x dx. So dt by 3, this becomes dx by x, and dx by x is already with us. So just write it as dt by 3. So integration will become like this. 1 by 3 I'm taking out, which we have just got below dt, and then we have sine t, because t is 2 plus 3 log x. What is the integration of sine x? It's negative cos t. Let me write it t as 2 plus 3 log x. So it will be 2 plus 3 log x, and this is negative 1 by 3 plus constant of integration. So this is how you are going to write. Please don't forget to write this let, now, and all the symbols. This is a question being repeated. If you put x square as t, you will get 2x. So this is question which I have already formally discussed. So just have a look at the solution or the reference. E raise x. Now e raise 2x divided by 1 plus e raise x. So if you have already done this question, let me tell you, you might have done like this: e raise x into e raise x. E raise 2x can be written like this. So this t is equal to e raise x. dt by dx will be equal to e raise x when we differentiate it. There is nothing with x, so it will be just e raise x. dx goes on the right, dt will be e raise x dx. So integration will become like this. E raise 2x we have written as e raise x, e raise x. dx was already there, so e raise x dx is dt. All together it's dt. So we have e raise x in the numerator, 1 plus e raise x in the denominator. So numerator e raise x is t only. This is t and this is 1 plus t. Now this is the catch. So always I encourage you not to take just e raise x or anything with 1 or a constant. So I'm now taking a different step, different route rather. 1 plus ex equals to t. So dt by dx will be equal to e raise x. See how easy it has become now. dt was in earlier assumption also e raise x dx, here also. But here t by 1 plus t denominator will be difficult to handle. And in order to make it much more easier for integration, the step, I'm just crossing it right now. The right step or right way is e raise x dx. This is dt. Now e raise x divided by 1 plus e raise x. 1 plus e raise x is t. So it is in the denominator. E raise x from here. 1 plus e raise x equals to t. So e raise x will be equal to t minus 1. So this is t minus 1 divided by t. And the integration of this term or their two terms will be quite easier. T by t dt minus 1 by t dt. T by t cancels out. You will get a dt. Integration of dt is going to be only t minus a log of modulus t plus constant of integration. And t was taken as 1 plus e raise x. Please remember, we dropped the idea of taking e raise x equals to t. T equals to 1 plus e raise x. 1 plus e raise x minus log modulus of this t, for which t I am writing as 1 plus e raise x plus constant of integration. Now most of the students will stop here. But those who have practiced, they know there is one more catch in this question. See, if you say 2 is a constant, 2 plus 3, 5 is a constant. So anything added with a constant will constant only. So we have a 1 in front. Constant plus 1 will be again becoming a constant. You can write it in the capital letters. You can write it as a c prime. It's up to you. So c plus 1, this is again a constant. I'm writing it as a c prime now. Other terms remain the same. E raise x, this, and then minus log 1 plus e raise x plus constant of integration. You can make it x capital or prime. So you have known the difference. Two path or two route I showed you. Whichever you like, you can follow it. But the latter one will be more beneficial as far as the solving of question in no time is required. One more catch is c plus 1, because 1 was already there. Don't leave it. Whenever it is a constant with a plus or a minus, add it with c and forget about that. Now this, I think we might have done multiple questions in the similar lines, similar terms. So when we take t equals to under root x, dt by dx will be 1 by twice root x. Okay, you already know that. So dt, 2dt will become dx by root x. So this dx by root x is twice of dt. So integration will become like this: sec square root x was t, and this dx by under root x will whole become twice of dt. So this sec square integration, we have a direct integration. Tan, simple tan. Okay, so tan t, 2 was already there, constant of integration. What was t? Under root x. So 2 tan under root x plus constant of integration is your final answer. So this is the reference for you. Tan cube 2x sec 2x dx. Now just think what we are going to put so that we can get the other part of this integral in an easy way as an assumption. So tan cube 2x is there. You know that tan square has a relationship with sec x. When we differentiate sec x, you'll get sec x tan x. So 1 tan x you can take apart and keep it with sec 2x and tan 2x. Tan cube 2x can be written as tan square 2x into tan 2x into sec 2x. Alright. So tan square 2x, this one. This is sec 2x, sec 2x and tan 2x. Okay, let's integrate this now. We have this dx. Okay. Sec x differentiation is sec x tan x. So when you put this t equals to sec 2x, dt by dx will be equal to sec x, sec 2x, tan 2x. Okay, one more thing is 2x will be differentiated and it will be 2 in the denominator. I have not written it, but I'll include it in later part. Okay, I have not written it. It's just don't think that I have forgotten it. I'll use it in the later part. Okay, so sec x tan x will be equal to dt by dx. But your question will be, if you take sec x tan x tan 2x dx as dt, then how you can write sec 2x? We can write, because you already taken sec 2x with tan 2x. So this tan square 2x can be written as sec square 2x minus 1. You know already the formula. Sec 2x tan 2x dx will be dt. So dt will be sec 2x tan 2x and dx. This whole is going to be dt. So this whole from here to here, it's dt. So sec square 2x minus 1 will be t square minus 1 dt. So when we integrate it, there is 2 also. Please remember, I've just not written it. We'll include it. 2. So t square minus 1. So this is the whole idea. Now this will be t square integration separately and minus this dt integration separately. It will be t square plus 1 by 2 plus 1, so t cube by 3 minus this only t plus constant of integration. T is a sec, if you remember, it was sec 2x cube. And where does this 3 combine with 1, the dt by 2? I told you I will include this 2. So it will be 1 by 6 actually. And then t will also be, as I said, 2x will be differentiated. That 2 will come here. What is the differentiation of the replacement of t? It's sec 2x. So this is 1 by 2, 1 by 2, 1 by 2. Let us include this now. And this half multiplied by 3 is going to be 1 by 6. This will give you half sec 2x plus constant of integration. So the final answer, you must have a look, and this will be 1 by 6 sec cube 2x minus sec 2x divided by 2 plus constant of integration. Okay, this is how you are going to write it. It's very important to write rather than understanding is one thing and writing is another thing. Now this is x plus under root x plus 1 divided by x plus 2. So we have to first get rid of this under root. First thing is this one. Then only we'll be able to integrate it properly. So t will write it as under root x plus 1. T square will be equal to x plus 1. And when we differentiate it, because we will be needing x, so you can write x as t square minus 1. When we differentiate t square equals to x plus 1, it will be 2t dt by dx. dt by dx equals to, this differentiation will be 1. Now what will be dx? It will be 2t dt. Now come here. So now this integration is going to become like this. This dx will be replaced by 2t dt. In place of x, you can write t square minus 1. This under root x plus 1 was t. and denominator x plus 2. Now you can just add 2 here. X plus 2 will be equal to t square minus 1 plus 2. So it will be t square plus 1. So t square plus 1 in the denominator. So now multiply the numerator all along. This 2 will take later. So it will be t cube minus t and plus t into t is t square divided by t square plus 1. Now we have to do something so that we can get rid of t square plus 1, or we can add or subtract something so that we can differentiate t square plus 1 and get something in the numerator. So I am adding a t and subtracting a t. So there is already a negative t. Okay. Then this, what to do with t square? Let's add 1 and subtract 1. In the denominator you will have t square plus 1. So t cube plus t by t square plus 1, one thing. This t square plus 1 I am bringing it in the front. T square plus 1 divided by t square plus 1. Then we have negative 2t minus 1 divided by t square plus 1. When you take t common from here, you will get t square plus 1. In the denominator it is t square plus 1. This gets cancelled. So you can just have a dt. Please remember, integration in dt is already everywhere. I am not writing it. That doesn't mean you will not write it. So it will be, this is negative 2t plus 1 by t square plus 1. So this gets cancelled. T dt integration will be direct. T dt integration and this dt integration. All this integration sign, don't forget, there is always a dt along with these separate terms. We'll talk about this 2t plus 1 by t square plus 1 in a bit. But integration of first term is t dt. The second one will be integration of just dt. So I'm separating this 2t plus 1 term into 2t by t square plus 1 minus 1 by t square plus 1. So this will be direct. T dt. Integration, 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 integration. So this integration of t dt is t square by 2. dt will be t. This both we got. How about this 2t by t square plus 1? So when we write t square plus 1 equals to some p, dp by dt will be 2t. This dp by 2 will be t dt. So this t dt you can write dp by 2, and already 2 is there. One more t is 2 was there. I will use it in the later part, as I indicated to you earlier. So this 2 gets cancelled in the this part. So dp by p, if you integrate it, it will be log modulus of p. P was taken as t square plus 1. Log t square plus 1. What was t square? T square is x plus 1. So it will be log x plus 2. What I am trying to suggest here is log t square was x plus 1, and when we assumed 1 is already there. So it will be log x plus 2 in the modulus sign. This log x plus 2. So this, let me just change it now. In terms of x I am writing. T square is x plus 1. X plus 1 by 2. This is our first term. T is what? Under root x plus 1. So it will be under root x plus 1. And for this we'll write minus log modulus x plus 2. Now one more term is remaining. Integration of 1 by 1 plus t square. So this integration of 1 by 1 plus x square was tan inverse x. You already know that. So this will be tan inverse t directly. 1 by 1 plus t square will be tan inverse t. And what was t? T was under root x plus 1. So I'm just adding it now while subtracting actually. Tan inverse under root x plus 1. So this whole is your final answer. Please multiply by 2. As I told you, 2 I am going to use a later part. This 2, this 2. So now just multiply everything by 2. This gets cancelled. You'll get a x plus 1. Then you have plus 2 under root x plus 1 minus 2 log modulus of x plus 2 minus 2 tan inverse under root x plus 1 plus constant of integration. Okay. So this is a solid question. It needs some practice. So you must have a look here. This is how you are going to go about it. So there are certain things which are not in this printed version. You have to go back and just understand how I did each separate part and what is the reason of having this answer. This one is more like a reasoning question. So 5x, 5x, and then dx. We have no option. We have to just take 5 raise x. So t will be equal to 5 raise x. Now a raise power x will be what? It will be a raise x will be a raise x. Integration you know already, but differentiation I'm talking about. Differentiation will be dt by dx, and a raise x differentiation is a raise x log ea. So a is 5 here. 5 raise x log 5. So dt log 5 will come in the denominator. 5 raise x will be there, and this will be dx. So this already we have. So this integration is going to be, so we'll align this with our assumption and what is given in the question. So dt by log 5. So 1 by log 5 here, and this is dt. Now 5 to the power 5x is t. 5 to the power x is t. So it will be, and whole 5 raised x dx was already dt by log 5. So 5 to the power 5x is 5 raised t. 5 to the power 5x is 5 to the power 5t. So not until now we have just reached the half part. So this is the second level of assumption. Take p equals to 5 raised t. dp by dt will be again the same formula we are going to apply. Here is x log a is 5 here, and x is t here. So dp, one more log 5 has come in the denominator, it will be 5 raised t dt. Now you see 5 raised t dt already we have here as dp by log 5, you just got it. So one more log of 5 will come in the denominator, so let us make it as log 5 whole square. Integration, this whole we already got, it is dp by log 5, we already written it, and this log 5 already included here in the denominator. 5 raised 5t will become 5 raised p, it was taken as p. So this 5 raised p, again a raised x integration we have to do. So a raised x divided by log base ea. So 5 power p will be x is p, 5 is a. So 5 raised p by log base e5. Let us write it here. Again one more log 5 has come, so let us make it as cube log 5 whole cube that we are going to do. And this whole is going to be getting it from here. So 5 to the power p plus c, but p was what? It was 5 raised t, so let me write it here. 5 to the power p was 5 power t, and t was what? 5 raised x. So 5 to the power 5 to the power 5 raised x. So the final answer would be 5 to the power 5 to the power 5 x, and in the denominator you have log 5 and this whole cube plus constant of integration. And how you are going to go about it, it's in front of you. There will be two level of letting or assuming. 1 by x under root x to the power 4 minus 1. How are you going to get x in the denominator? X to the power 4 can be written as x square to the power whole square. That we know. X square differentiation will be 2x, but 2x is in the denominator. It means x is in the denominator. That is the problem we are facing. So what we are going to do here is, we'll make certain adjustments. What will be the adjustment? We'll multiply numerator denominator by x, and denominator under root x square whole square minus 1 will write. So this integration will become x, we have introduced by ourselves x dx. This x in the denominator will become x square. This is under root x square whole square. So x square whole square we are writing minus 1. Now let us go to our normal routine. X square equals to t, dt by dx will be equal to 2x, dt by 2, this x dx goes here. So this x dx in the numerator can be written as dt by 2. This one dt by 2. So this integration will become dt by 2. I am taking half here. This whole in terms of x square we write 1 by t under root t square minus 1. Now what do you think? Do you smell something good here? Yes, because sec inverse, if you integrate 1 by t under root t square minus 1, you will get sec inverse t. Because when you differentiate sec inverse t, you are going to get 1 by t under root 1 t square minus kind of thing. So same we are going to use here. When you integrate it, it will be directly sec inverse t. So this half, this whole has become sec inverse t plus constant of integration. Half sec inverse in place of t, write x square plus constant of integration, and say it as a final answer. So this was very straightforward. If you know that x and x can be multiplied, numerator denominator, that will give you an easy result. Just x square equals to t, all will be like easy. So typical question is starting, we'll take it later. Thank you so much.